Welcome to This Explainer. You know, we usually look up at the night sky and just assume those twinkling lights are permanent, unchanging fixtures. But the fascinating reality is that stars actually have a life cycle. They're born, they live out their lives, and eventually they die. Depending on their mass, they're either going to swell up into massive giants or shrink way down into unbelievably dense dwarfs. Today, we're going to unpack exactly how and why that whole process happens.
Before we launch into the cosmos, our source material actually anchors things with an interesting perspective from Isaiah 48. The grass withers, the flower fades, but the word of God stands. It's a profound philosophical contrast used to frame the lesson. Basically, while even the most massive, awe-inspiring stars in our physical universe are eventually going to fade away, spiritual truths are viewed as permanent.
Here's a quick roadmap for today's explainer. We've got the big idea, rise of the red giants, the white dwarf core, stars in our sky, and finally, education, morality, and peace. Let's jump right in.
Section 1. The Big Idea. Before we dive into the nitty-gritty mechanics of collapsing cores and expanding gases, we really need to ask a foundational question. Why does the death of a star actually matter to us down here on Earth? Well, learning what happens after a star's main sequence is incredibly revealing. Just like us, stars go through life stages, and their endings are honestly just as fascinating as their beginnings. Studying this helps us understand how the very elements that make up our world are created. It sheds light on those mysterious black holes, and it even gives us a sneak peek into the eventual future of our own sun. Plus, by observing these cosmic shifts, scientists learn fundamental truths about time, gravity, and the evolution of space itself. It's basically the ultimate history and science lesson rolled into one.
Moving on to Section 2, Rise of the Red Giants. Let's get into the actual physics of stellar aging. What exactly triggers a star to become a red giant?
It's essentially an epic cosmic battle, a really delicate balancing act. Step 1. The star's primary energy source, hydrogen, finally starts running low. Because the fuel is depleting, nuclear fusion slows way down. Step 2. Without the outward push from that fusion, gravity starts to win the tug of war, causing the star's core to violently collapse inward. And Step 3. As that core gets crushed, a massive amount of energy is released, which blasts the star's outer layers incredibly far outward.
And just like that, this dramatic process births a red giant. But here's the really counterintuitive part. Because those outer layers have expanded so incredibly far, the energy gets spread out over a much larger area. So despite swelling up to this absolutely massive size, the surface of the star actually cools down. That temperature drop shifts its light, making it appear distinctively red.
Section 3. The White Dwarf Core. Now the story definitely doesn't end there. What exactly happens to that collapsing core left deep inside the red giant?
If we just follow the timeline, Step 1 is that eventually the massive red giant totally loses its grip on those huge, swollen outer layers, and they just drift off into space. Step 2, once those cloudy layers are gone, the shrinking, naked core of the star is left completely exposed. And Step 3, this core continues to compress under its own immense gravity until it becomes this tiny, dense remnant that is still intensely glowing. This leftover, super dense, glowing skeleton is what we call a white dwarf. Just try to wrap your head around this for a second. Imagine taking the mass of an entire star and squishing it all the way down to the size of our tiny planet Earth. The density is just mind-boggling, and it still glows incredibly bright from all that trapped residual heat from its earlier life. It is such a stark contrast between these two interconnected phases. On one hand, you've got the red giant, defined by its massive size, cooler surface, red hue, and expanding layers. On the flip side, the white dwarf is the exact opposite. It's tiny, Earth-sized, super dense, and packed with intense trapped heat. It's amazing how one phase directly births the other.
All right, Section 4. Stars in our sky. It's one thing to learn the mechanics out of a textbook, but it's another entirely to realize you can actually look up and see this happening right now. You can literally witness these transitions out there in the dark. Take Betelgeuse, for example. It's an incredibly famous red giant located over in the Orion constellation. When you look at it, you're looking at a star nearing its final stages with its outer layers all swollen and cool. Then we have Sirius B. This is a perfect example of a white dwarf. It's a super dense, glowing core acting as a companion to the much brighter star Sirius A. These aren't just theories, guys. They're our neighbors in the galaxy.
So if this is happening to stars out there in the cosmos, it begs the ultimate question that hits closest to home. What is the ultimate fate of our own sun?
Now, don't panic. This isn't happening tomorrow. But billions of years from now, our sun is absolutely going to follow this exact same cosmic biography. First, its hydrogen fuel will finally run dry. Then, as fusion slows and the core collapses, it's going to expand outward into a massive red giant. Finally, after shedding those outer layers, it'll shrink all the way down into a super dense, glowing white dwarf. It is just a spectacular cycle of stellar evolution.
Section 5. Education, Morality, and Peace. As we zoom out from the cosmos, our source material shifts focus to argue that gathering scientific knowledge is really only half the equation.
The heroesmartacademy Godly Learners series framework introduces a vital premise found in Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. The curriculum really emphasizes that while science tells us the mechanics of how the heavens operate, it's spiritual wisdom that gives people the peace to navigate their actual place beneath them.
And this is exactly why the program intertwines biblical morality with education. Their philosophy is super simple. Education without morality will hurt. Think about it. What's the actual point of being incredibly smart, of knowing the entire life cycle of a star, or the deep physics of gravity, if a person continues to make choices that hurt themselves and the people around them? True education, in this view, has to elevate both your intellect and your character.
So the source leaves us with this final, really provocative thought to chew on. Next time you step outside at night and reflect on those fading stars above, the red giants and the white dwarves, ask yourself this: will you choose to combine your rapidly expanding knowledge of the universe with the grounded, moral wisdom required to actually use that knowledge well? Thanks so much for joining me for this explainer today. Keep looking up and keep learning.